faster and more powerful aircraft was ever increasing. When Air Commodore Sir Frank Whittle had a big idea for a jet engine, he started a revolution in aircraft engineering. In his lifetime, Sir Frank was to see the jet engine industry grow into a multi-million-pound business, from an invention that he could not afford to patent because he needed the money for a medical bill. With the introduction of the jet engine, intercontinental flights became more practical, safer and faster. The jet engine that Sir Frank saw in his big idea has progressed at supersonic speed to become the high-tech, fuel-efficient power plants of the future. Today, Rolls-Royce Trent 900 engines power the Airbus A380. At takeoff, the A380's 4 engines are delivering thrust equivalent to the power of more than 3,500 family cars. Each of the 70 high-pressure turbine blades produces about 900 horsepower, more power than a Formula One racing car. If you applied the high-pressure turbine blade cooling technology to an ice cube, you could put it in an oven at 200 degrees centigrade and it would never melt. The 116-inch fan operates at nearly 3,000 RPM, which means that the blade tips are travelling at about 1,000 miles per hour, or about 1.3 times the speed of sound. When it comes to military hardware, the Whittle's big idea is taking technology to the limit. A fully fused and integrated data flow, processed by all digital systems, gives the Saab Gripen the power, intelligence and agility to fight the information war for the pilot as well as the commander to the maximum operational effect. The 414 engine is capable of producing more than 22,000 pounds of thrust. In a recent £1 billion contract, the Kingdom of Saudi Arabia has purchased Eurofighter Typhoon aircraft powered by twin EJ200 jet engines. The EJ200 powered Eurofighter Typhoon began operation with the air forces of Germany, Italy, Spain and the United Kingdom in 2003. The total EJ200 fleet has accumulated more than 50,000 engine flying hours, and to date, approximately 125 EJ200 engines have been delivered for the UK RAF. Back over at Rolls-Royce, the Whittle's big idea has taken a new turn, with the development of specialised engines for the Short Takeoff Vertical Landing Aircraft, or STOVL. Experience is drawn from the bank of knowledge accumulated in developing and producing the Pegasus, the power plant for the unique Harrier jump jet. The turbofan has 4 rotating nozzles, 2 on each side, that allows bypass air and exhaust gases to be vectored downwards. It also incorporates contra-rotating engine spools to minimise gyroscopic effect on hovering stability. The Osprey is powered by 2 Rolls-Royce Allison turboshaft engines. The CV22 takes off vertically, and once airborne, the nacelle engine and prop rotor group on each wing and can rotate into a forward position. With more than 6,200 shaft horsepower per engine and can cruise at 241 knots. Powering corporate and regional aircraft like the Cessna Citation, the Rolls-Royce AE 3007 turbofan is designed to meet the stringent requirements of this type of operation. A rugged, wide-chord fan with solid titanium blades provides excellent protection from foreign object damage. The engine is designed to pass ingested debris away from the core and into the bypass duct, where it can exit harmlessly. An efficient 3-stage low-pressure turbine drives the fan, which has a 5.1 bypass ratio. This results in low acoustic signature levels, fuel efficiency and excellent performance. The hollow, titanium wide-chord fan blade, pioneered by Rolls-Royce and introduced into airline service in the 1980s, set new standards in aerodynamic efficiency and resistance to foreign object damage. Designed specifically for high bypass turbofans, the breadth of these blades sets them apart from the narrow and less efficient equivalents of earlier times. As the world of jet aircraft travel powers into the future, a future that would not be possible without the legacy of Sir Frank Whittle's big idea.